Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the basic concept of the operational amplifier and the pin description of IC 741. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the block diagram of an op-amp. In this diagram, we can see the block diagram of op-amp, which consists mainly four blocks: the input stage, intermediate states, level shifting stage, and output amplifying stage. Here is the two inputs of the op-amp: inverting input and non-inverting input, and one is output. If we look carefully at the diagram, then at the input stage it has two input, similarly it has two output. But in the intermediate stage it has two input but it has the single output. Okay, let's see more description about this block diagram. The first one is the input stage. The input stage is a dual input, balanced output differential amplifier. That means at the input stage we have two input and two output, hence it is named as dual input balanced output differential amplifier. It is called as differential amplifier because it amplifies the difference between inverting terminal and non-inverting terminal. These two inputs are inverting and non-inverting terminals. This stage provides most of the voltage gain of the op-amp and decides the input resistance value Ri. This input resistance value, it is also known as the input impedance. In this stage, the differential amplifier provides the high input impedance. Okay, that means the resistance between these two terminals or the impedance of the input should be very high. I hope you all understand the input stage. It is a dual input balanced output differential amplifier which amplifies the difference between inverting and non-inverting terminal, and it should have the high input impedance. Let's see the second block of the op-amp, the named as intermediate stage. This is the intermediate stage or second block of the op-amp. This is usually another differential amplifier like the first differential amplifier. It is driven by the output of the input stage. The stage is dual input unbalanced output, that is single ended output differential amplifier. That means this differential amplifier is similar to the input stage, except that in the input stage it has dual input balanced output, that means two input two output structure. But in the second stage there is two input single output, hence it is called as dual input unbalanced output stage. This stage provides additional voltage gain to the input signals. Here the direct coupling between the first stage and second stage is used. This will lead to an output DC level which is well above the ground. Hence, in order to reduce this DC level, a level shifting stage is used. That means the input stage and the intermediate stage both are differential amplifier and these are directly coupled with each other. Hence, the DC level is well above this ground level. For that purpose, the third block, the level shifting stage, is used to reduce this DC level to the ground. Let's see the third block, the level shifting stage. Due to the direct coupling between the first two stages, the input of level shifting stage is amplified signal with some non-zero DC level. Level shifting stage is used to bring this DC level to 0 volt with respect to the ground. This include an emitter follower element. This stage is also known as buffer stage. That means in first two stages These are directly coupled with each other. Due to this, the DC level is well above to the ground level. To bring back this DC level towards the ground, we use the level shifting stage, which is the emitter follower element and which is also known as the buffer stage. Now let's see the fourth stage, the output stage. This stage is normally a complementary output stage. It is generally a push-pull amplifier. This will increase the output voltage swing and increases the current supplying capability of the operational amplifiers. The resistance of this stage is very low as compared to other stages. That means the first stage is generally a push-pull DC amplifier, and the one more property regarding to this stage, the output resistance should be very low. I hope you all understand the block diagram of the operational amplifier. Let's see once again. Here is the block diagram of the operational amplifier, in which we can see there are four blocks. The first block is the input stage, second block is intermediate stage, third is level shifting, and fourth is output stage. We know that the input stage is a dual input balanced output stage. That means it has two input, two outputs. Similarly, it is a differential amplifier which amplifies the difference between its input signal. The output of the input stage is given to the input of the second stage, named as the intermediate stage, which is dual input unbalanced output. That means it has two input and single output. It is again a differential amplifier. That means it amplifies the difference between these two inputs. The here is in these two amplifiers the direct coupling is used. Due to this, the DC level is goes to high above the ground or zero level. To bring this DC level towards the ground, we use the third stage, the level shifting stage. Generally, it is a emitter follower using a constant current source, which is used to bring the DC level back to the ground level or zero level. And the last stage is the output stage. It is a complementary symmetry push-pull amplifier. There are two main properties regarding to this. That means the input impedance of the amplifier should be very high and the output impedance of the amplifier should be very low. I hope you all understand the block diagram of the operational amplifier. Thank you.